Have you ever seen an LED slowly glow to life like it's breathing, then fade away as if it has a pulse? Hey guys, in this video I'll show you how to make a simple fading LED circuit with a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 9 jumper wires, 1 47 kilo ohm resistor, 1 330 ohm resistor, 7 red LEDs, a 9-volt battery buckle connector, a 9-volt battery, 1 555 timer IC, 1 BC 547 NPN transistor, 1 100 microfarad capacitor, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 100 microfarad capacitor into pin 2 or trigger in the negative rail. The anode is in pin 2. Bend the ends of a 47 kilo ohm resistor. Insert a 47 kilo ohm resistor to pin 3 or output and a few rows below the 555. Insert the base of a BC 547 NPN transistor to the same row as the resistor. Insert a jumper wire into the same row as the collector of the BC 547 and the positive rail. Insert a jumper wire into pin 2 or trigger in the same row as the base of the BC 547. Bend the ends of a 330 ohm resistor. Insert a 330 ohm resistor into the emitter of the BC 547 and a few rows below it. Insert a jumper wire into the same row as the resistor so it bridges the left and right sides of the breadboard. Insert a jumper wire 2 rows below the resistor and connect it to the negative rail. Insert another jumper wire into the center of the breadboard, 2 rows below the previous jumper connection. Insert a red LED into the same rows where the 2 jumper wires are connected. The anode is in the same row as the resistor. Repeat this step 6 more times. It's time to connect the power supply. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. We have successfully completed the circuit. Let's dive into the circuit and break it down step by step. This circuit is a simple fading LED built around a 555 timer and a BC547 transistor. The 9-volt battery provides the power supply. Pin 8 is tied to the positive 9-volt rail, and pin 1 is tied to ground. Pin 4 is connected to VCC as well, so the 555 is never held in reset and is free to run continuously. Pin 2, or trigger, and pin 6, or threshold, are tied together and connected to capacitor C1. This junction is also connected directly to the base of the BC547 transistor and resistor R1. Resistor R1 connects between the 555's output pin 3 and this shared node. This means the 555 output does not drive the transistor base directly. It drives the timing capacitor C1 through R1. When the output is high, C1 charges through R1 toward the 9-volt. When the output is low, C1 discharges through R1 toward 0 volt. Because C1 is relatively large and R1 is fairly high, this charging and discharging is slow, producing a smooth rising and falling voltage across the capacitor instead of a sharp step. The voltage on C1 is constantly monitored by the 555 via pin 2 and pin 6. When C1's voltage, starting near 0 volt, climbs past 1/3 of VCC, the trigger comparator considers the circuit triggered and allows the output to stay high. As charging continues and the capacitor voltage eventually rises above 2/3 of VCC, the threshold comparator fires and flips the internal latch, forcing the output at pin 3 to go low. Once the output drops low, the right side of R1 is at a higher voltage than pin 3, so C1 now begins discharging back down through R1 into the low output. As C1 discharges, its voltage falls. When it drops below 1/3 of VCC again, the trigger comparator flips the latch back the other way, and the output returns high, starting another charge cycle. With R1 equals 47 kiloohms and C1 equals 100 microfarads, the charge-discharge cycle takes several seconds, giving a slow oscillation. In other words, the 555 here is wired as a relaxation oscillator using only one resistor and one capacitor, with pin 2 and pin 6 tied together and pin 7 left unused. Because the base of the BC547 transistor is connected directly to C1, the transistor sees this slowly rising and falling voltage on its base. The collector of the BC547 goes straight up to the positive rail. Its emitter goes down to resistor R2 and then into the common node feeding all of the LEDs. The other ends of the LEDs are all tied to ground. As C1 charges through R1 and its voltage rises, the base voltage rises smoothly. Once the base is about 0.7 volts above ground, the transistor begins to conduct. The emitter follows, pulling the top of R2 and the LEDs upward. The higher the base voltage climbs, the higher the emitter voltage, and the more current flows through R2 and each LED branch. This gradual increase in current makes the LEDs slowly brighten, giving the fade an effect. I hope this video has shown you how to make a fading LED circuit with a 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.